is Maxence, and I am very pleased to give this talk for the 2022 edition of React Native EU. First of all, I would like to thank everyone at ColdStack for this great opportunity and for this incredible event. And I will be presenting a project that led us to build an image viewer with deep zoom capability. We will develop precisely what we mean by that during the presentation, and without writing a single line of code. So the result is basically a pure JS React component. Let me just start with a small illustration of the situation we faced. As developers, we often ask ourselves if we should do something ourselves or use an existing piece of code. That is probably one of the questions that I find myself trying to answer the most. The internet has a clear answer for that. It's always don't reinvent the wheel, use what exists. There are numerous blog articles and forum answers stating that you always should use existing libraries, even if they are not matching your exact use case and so on. Well-maintained, well-tested framework used in thousands of production applications is certainly better than starting from scratch. There's no doubt about that. React Native is a prime example of that. But what bothers me is how generic this answer has become. To take this illustration, yes, don't reinvent the wheel. What if it doesn't match what I'm trying to do? Or what if it's broken or it's not exactly what I expect to be? There are infinite types of projects, and it's not the same to choose a framework for your whole app and choosing a library for a single view or component that maybe some users will never see. It doesn't have the same importance and the same consequences. So this talk is kind of a testimony of our journey exploring what the awesome React Native community had to offer in order for us to build a complex UI component. And as you might have guessed by now, we did not end up using what we started with. So I will not be taking you to to Egypt today, but this has to do with the deep zoom feature that our image viewer needs to have, which we already mentioned in the title of the talk. I think many of you have at least already heard about image pyramids or tile pyramids. I will explain the basics before we dive into it, because it is at the very center of what we were trying to display today in our component. I will be starting by introducing who we are and what we do, of course, as well as a small feature we had in our product, and which is the starting point of the project I'm going to talk about. So basically that will be the V0. We will see together what the goals are for the V1. Then we will see two different stages in the project. First, the proof of concept I did when discussing the project with a prospect to showcase what we were going to do, and the phase of implementation in our production app. As I said earlier, we kind of changed the way we plan to do it between those two phases, and I will explain why. Finally, I will recap what we achieved and what we still have to do in order to make it even better, as well as ideas for further use. So I have not yet introduced myself properly, so it looks like the right time to do it. My name is Maxence, and I started a SaaS company with my wife a few years back. Our offices are in La Rochelle in France, and our product is meant to centralize and structure data for construction and renovation professionals. That means architects, interior designer, general contractors. Our goal is to give them the ability to easily work on and off-site and on the go, losing less time in the process and making less mistakes. So it's basically an all-in-one solution, digital solution for construction professionals. So it features lots of project management features like task management, time planning, cost tracking and analysis, stakeholder access and communication through a feed, report generation, floor plans and blueprints. Floor plans and blueprints will be kind of in the center of what we will build together. It has a web app as well as a mobile app. And about me, I had quite an ordinary developer path, I would say, starting 10, 15 years ago with static website, HTML, CSS, classic PHP, MySQL, then moving on to JavaScript and first mobile app using Ionic. I know nobody's perfect, but then I discovered React and never left. So I did some freelance stuff at the start and worked for a startup company which develops add-ons for Microsoft Office. So that was in .NET languages and frameworks. Real, this company we are now building, started as a side project in 2017 actually, using React Native version 0.34. Now it's on 64, so we are not yet fully up to date, but that will come. I would not say I'm an expert in React Native architecture. I contributed once to the React Native CLI repo. As I said, this talk is to show the great things we can achieve with the tools at our disposal, thanks to the community as React developers. So let's head to it then. So each project on the app has a feed to display activity as the project goes forward. Members of the project can post text and photos, link it to a particular task, add a marker on a blueprint like a floor plan to show a precise location. This is the initial mock-up for the V0 of this feature. So basically you have your feed, you have your form at the top, then you reach a full screen form where you can add type some text, add photos and so on. Now what we want is to locate it on a blueprint. So we give the possibility to select an image from the files of the project. And that now is the most important view for this talk. It's the view where you can put your marker on the blueprint, the floor plan viewer. So in the V0, the blueprint is supposed to be a simple image, so JPEG or PNG, and the implementation would be straightforward, but as you can see, the user interaction to mark the location does not involve to tap on the screen, but rather to move the image behind the fixed and centered marker. This is to give more precision to the user, and it is often seen in applications when you order a ride or, for example, as you need to pinpoint your precise location on the street. So, and that's the end of the markup when you finally publish your post. So the initial version, as I said, was only meant to support image formats. So this is why we decided, this was decided, because it seemed obvious how to implement it, and it's not that hard to convert a PDF to an image or export an image directly from CAD software, so it was a good entry point to this new feature in our product. You can see here how it looks like on the web, for example. It's simply an image in a model, and on the web the code is fairly simple. Here's how it mainly looks like. You have a container and with CSS positioning set to relative. and an image displayed within. You can then use the click event on that image to get the coordinates of the click in pixels and store it in a state variable. This then gives you the possibility to absolute position the marker component of your choice to view the marked location. You then just need to store this coordinate somewhere or send it to your backend along with the rest of the form in order to keep it for further use. There's actually a bit more than that in the real component, but really not much, only some ratio to take into account the resizing of the image if it doesn't fit into the view or the model or something like that. So it's simply dividing the coordinates by that ratio or multiplying it. So that's fairly simple and quite straightforward for the web part. But what interests us is now the mobile one, which has slightly complexer interaction. On mobile, we could have easily done the same with an on-press event and absolute positioning for the marker. But as we said, precision was important, even for the V0 of this feature. So what we need is a simple pan and zoom image viewer, which we can track the center, from which we can track the center of viewport, the center of the viewport position in order to know the current coordinates of the displayed marker, which is fixed in the center. There are lots of gallery libraries and image viewers out there built upon native libraries, which with great support for image formats and which have built-in networking optimizations like prefetching and caching and so on. And we actually use one of those to display photos in full screen when you tap on it in the feed or in the project files. But they are all uncontrolled components and they don't give you any API to access the current viewport. It's all in the native part and does not come back up into the JavaScript code. So you can't know what is in this, what position has the center of the viewport with these components. Hopefully, thanks to the community, there was a spot-on example in the docs of reanimated v1 called image viewer with pan and zoom capabilities, as well as some bonuses like bouncy edges and bouncy scale limits. We only needed to change the edge limits so that the edges could reach the center of the view, allowing to pinpoint right up the edges. But let me show you. So let's take a look at this example. So as you can see, we had some examples from the V1 of React Native Reanimated, and that one was called Image Viewer and came with some initial built-in features like bouncing when you zoom too much or when you take the edge of the screen and so on. So that was really close to what we were looking for, with a pinch gesture handler and a pan gesture handler that works simultaneously. I got it. So hop. Just jump to the one in our app. So the code is basically taken from the example, and as I said, we only changed very small parts to achieve what we were looking for. So here I'm in an old project of ours on the application, and we will take a look together. Hop. So that's the image viewer from the example with some slight changes. As you can see, it has this bouncing effect when you zoom out too much or when you zoom in too much. So that was basically it. But the edges don't come back because we needed to be able to pinpoint something right near the edge. So that's why the bouncing comes back to the edge instead of going back to the side of the screen. So that's what we had to change. Quite straightforward. We can even have a look at the differences that we had to make, and you will see that this example was really mega useful in our case. I just closed it instead of going into it. Hop. So now if I save, and if we take a look at what's changed. Okay, so it won't work anymore. That's quite expected. You can see that we actually added some throttle to get the position back, and not too much. We changed some max scale, and yes, that's because we now use reanimated v2, so backwards compatibility. The width and height are now calculated by the components above to make it so it takes the whole screen, and passed down to keep it working. And you can see it's about here. So we've added some stuff right there, but that's only the stuff to make it a control component, or at least to get information about what the actual position is. There is some debug stuff, but mainly, yes, that's mainly the width and height that are computed above, and some styles, and this part here, which were where the panning was stopped at some point, which we had to simply change a bit to change the condition about when we had to change it, to stop it. So that's it for V0. Quite straightforward, thanks to the help of great projects. Let's move on now to the actual more advanced components that we have built. We are now going to dive deep into image pyramids. So the V1 of our feature has some more requirements for the input, which it is supposed to handle. So same image support as V0, JPEG and PNG. We need PDF support for single and multi-page, but this does not specifically affect our viewer, as we decided to treat each page as separate blueprint, and the processing is done on the back end, so we will still have the same output for our viewer. We need to handle big and complex floor plans. Big means mainly for raster images. They might be several thousands of pixels wide and tall, so that would be something to take into account, and complex because for PDFs we've had to discussions with a prospect who had huge blueprints with very detailed vector graphics, and that would need a lot of time to render, and that might cause some problem as well. So that's an example of a blueprint that was given to us to use for testing. And all of that needs to be done with a high precision of zooming in order to be able to locate markers very precisely. So On the performance aspects, we need to focus on 3 things. First is the load time. On-site downloading and viewing should not require to wait when there's a decent connection. We actually prepared an offline capability for the proof of concept, but we did not bring it to production yet. Interactions, well, 60 frames per second is always the goal for reactive filling. And memory, low-end devices should not run out of memory, so it was tested on an old Android tablet which was known to have difficult time rendering PDFs like the one on the previous slide. So given all the requirements for the input and the performance of our feature, a naive evolution of v0 did not seem to meet the requirements, considering what we had to do. What I mean by an evolution of v0 would be like a controlled native PDF viewer component with an on position changed and an on zoom prop, for example, but we would need to be sure that the marker is placed in the center, plus we don't know how it would handle large number of vector details and so on. There are not many PDF viewers like that which send back their position and so on, like for the image galleries. Second, we could also keep our image viewer and convert PDFs to image, but then downloading raster versions for big blueprints could be really slow, if not impossible. So that's why we went for image pyramids that we will see right now. There are several formats for image pyramids like Deep Zoom, Zoomify, Google, but the core principle remains the same. The original file is split into square tiles. So the original file will be the bottom layer on the examples that you can see. A new level is created with half the width and half the height split into tiles like the previous. So the number of tiles is divided by 4 on each stage, and you repeat that until the image fits into one tile. This is really great because it gives you a predictable maximum number of pixels to load for a given viewport and tile size. The viewport size depends on the size of the view or the screen and the pixel ratio of the device. Tile size, on the other hand, is defined by our processing on the back end and has a fixed value. So the proof of concept was made to validate our ability to develop this feature completely, which meant back-end processing, serving of tiles, as well as front-end, web and mobile components to display and interact with the pyramids. The pyramids are in fact very common in our day-to-day tools. All navigation apps use it to display maps as tiles, loading them when needed. Each time you zoom in or out or move the map around, you see it loading when you have a bad connection. Here are a few examples. So OpenStreetMap uses leaflet. Hop, which is a great JS library for displaying image tile pyramids. So you can see the tiles loading. Hop. Not on the map side, we also have stuff like OpenSeaDragon, which is an image viewer for high resolution image viewer. So you can zoom really deep into the image. So another real life example of OpenSeaDragon on an art website is this one. Up. There you can see as well that you can really zoom in really deep. So these are some examples of deep zoom image viewers on the web. As you can see, if you look into the Chrome developer tools, you see the request URL for the tiles, which has often this kind of URL. Okay, sorry, I went too quick. Hop, just get back there. There it is. So that's the kind of URL you get for these tile pyramids. On the mobile side, we have found this project which is an iOS deep zoom image viewer, which is kind of the same as OpenSeaDragon. From what we could see, you see that you can really zoom deeply, into the image, which could be what we were looking for. And also we have found an article from someone trying to do something pretty similar with what we were trying to achieve, as you can see with this floor plan, and we had done it in Expo using React Native maps. So yes, there are a lot of stuff around image pyramids and maps. We are not using a map or navigation system, but it looked actually to be the best direction to go. So we did our proof of concept using React Native maps, and I will show you how right now. So as I was saying, on the web part, leaflet was the decided solution, and on the mobile, the solution with the React Native maps was the way we decided to go, as there is no version of leaflet made for mobile, no native version of leaflet, and we wouldn't really want to use it inside a web view. So let's see it up. Where did I put it? Okay, right there. So that was our initial version, and we are now going to take a look at the proof of concept that we made using React Native maps. If I can find view, I think it's this one. Yes. Okay, so you can see here on the right what the result looks like. Up. So that's React Native maps. You can see it on the bottom. We still have the Google logo, which is not ideal, but we'll discuss that later. And we were able to display our floor plan and add markers to it using this component and having this tile pyramid display correctly and functioning all right. So on the code side, I just wanted to show you up. So on the code part, you can see that we are using React Native maps. It's not a very big file. It's quite easy to use as well. So the harder part of React Native maps is mostly getting it to build inside your own application. But we use the component map view. You can see that we have some props, so provider. We use the Google provider so that we can use it. You can use the same on iOS and Android, because we could have used the Google Maps SDK on Android and then the Apple Maps on iOS, but then we would have faced maybe specific problems from one or the other. So that way we at least have the same provider on both sides. Map type known is used because we don't want to display the Google Map tiles, but instead we want to use our custom tile layers. So we have a URL tile inside of our map view, which we will provide our URL template. So the URL template, you can see it at the top of the iPad and on the side. It's mainly a URL where you put your coordinates, your tile coordinates. So Z will be the zoom level. So the zoom level 0 is where you have only one tile. Then 1 you have 4 and so on. And Y and X are the coordinates of the tile within this level. So that's what we provide here to display it, the tile size that we use. And you can see that you can have a minimum zoom level and a maximum zoom level, so that it stops zooming when you have reached the resolution of your image. So it works quite well. We can even add markers by using the on-long press, but as we talked about earlier, that's not the final interaction that we want to have, and that might come with problems later on. So to recap quickly, on this component, this proof of concept for using React Native Maps as our component, as our library for this image viewer. You can see that it works quite well, as the Google Maps SDK is evidently working well with tile pyramids. We have achieved to add markers and display them, but we still have the Google logo, and we have tried, I didn't show you that, but we even have started to try to put our own interaction as we showed earlier, with the marker centered on the view, if it wants to refresh. Yes, you should see it now. Up. We started this. So here it is. So we started to position a marker and try to get the region from the displayed region from the map view, but that was not ideal, as we needed in fact to hide that Google logo that we couldn't do otherwise than with some hack by setting a position in the bottom and hiding it by making it overflow, but then we have to compensate the location of the marker in the center. And as we started to try to make those small details about interaction and how we wanted our component to feel, we started to see that it was really not made for that use, and what it was really made to display maps and not something else. So let's get back to the presentation and move on. So as I said, some time later, we managed to plan the integration of this project into our production app. It was intense, because as we fine-grained the viewer on the web with leaflet, we realized that React Native Maps did not offer the same conveniences, and we started to struggle to achieve the experience we wanted to give to our users. So some drawbacks that we had with React Native Maps were that, it was not well suited for the custom tiles. So we were able to specify a URL tile, but we still needed a Google account registration to use the SDK. We still had the Google logo. maybe that was some kind of bug. I'm not sure. We had to verify to check, but I think the Google Maps tiles were still needed in background. Were still requested and fetched in the background. The position selection UX, as we just saw with the centered marker, was not really easy to achieve with that Google logo hack. And most of all, there was a really inadequate coordinate system for positioning the markers. It uses the Mercator projection, which makes distance scales as you go away from the equator line. For example, a 100-kilometer line at the top of the world, at top north, will be much bigger than the same distance around the equator. So using latitude and longitude would not be considered for storage in our database. For those marker coordinates, it wasn't logical. So we would need to convert it to display it and to convert it back when we want to store it each time, and it was really not convenient to use it like that. There are many things in the API of React Native Maps that are really made for maps and not for something else. It's logical, but it's not ideal for us in this particular case. And finally, the maintainers were not having the time to address issues, and that did not play in favor of us choosing the library. Since then, it has been changed, and some people are actively working to maintain it, and it's still a great library, but we just thought that it was not perfect for our use case. So all of this led us to the decision to move away from React Native Maps. But what were the alternatives that we had? Native modules, as we saw earlier, there was one for iOS, but it's hard to find separate projects with similar functionality and equivalent quality, maturity. At least with React Native Maps, we were using Google Maps SDK on both platforms. And also I don't have much experience with native mobile development, so if we had to dig deep into the library code to understand some stuff, it was not really practical. Since I had used Ionic in its early days, I had experienced some weird stuff due to the default behavior of web views regarding interactions. It made the app UX feel really poor, so I tried to avoid it as much as possible, especially on a component with such specific interaction needs. So using leaflet in a web view wasn't really an option as well. We already had part of the solution with our initial image viewer. What we needed from there was to display a layer of tiles instead of a single image. The more I thought about it, and the more it seemed straightforward, to replace one with the other. Translations are nothing more than basic geometry. Well, the geometry in the end was actually the part where we lost the more time, because when you combine translations on multiple layers, you start losing track of what's what. But in the end, it paid well, and we managed to achieve what we wanted. The new reanimated API is much clearer to use. In the first component, we used the V1, and the V2 is actually compatible with the V1, so we can have our legacy component still working while we migrate all existing data. So that was really a great thing for us. Let's see how it looks like for the final production component. So I don't have much time left, so I will be quite quick, but that is the latest version then of our plan viewer. What you can see here is that we used, in fact, like in the previous version, the V0, a container view to handle positioning of the image layers and reacting in response to gestures detected by the gesture handlers. So that is basically a transcription from V1 image viewer to the V2 API of reanimated. As you can see in the JSX, we still have a view and then our gesture detector around an animated view, and then inside of that we will have our tile layer component and our markers. So the way this container is, the behavior of this container is really close to what we had before in our image viewer. And inside of that we have the tile layer, which is responsible for positioning the tiles relative to this container. That means to display the 0, 0 in the top left corner, and then the ones after that. So we have a first level of translations in the styles. So now in the reanimated v2 we use a helper which is called use reanimated styles. I will find them. So to come to the top of the component, at the top we initialize some basic constants, so the scale. We have it as a shared value, which is an animated value from reanimated v2, and also as a state, because we will need to get it back in the JS to store it afterwards. So the same thing for zoom level, which will also have a shared value version, an animated value version, and a state value. We have also the viewport. So we have two viewports: the main viewport, which is the pixels or points of the displayed area, and the tile viewport, which we will use to store the coordinates of the visible tiles, because we have added some virtualization to avoid memory explosion. So we will compute the visible tiles to only display them. And that is used in the tile layer component. The rest here, offset start, focal offset, scale to top left fix, and so on. That's the same as we had in the image viewer to position the container, depending on the pan and zoom that we applied before. And as you can see, that's the gesture handlers. That's also a transcription from before, from the previous version. And then that's it for the structure of the component. The markers as well are displayed relative to the container. So let's see how it looks like. So I have the same plan as in the proof of concept, and we can see that we are able to achieve something really similar. So we see it loading sometimes and so on, but here we have really our own component that we can use and modify, and we are not dependent on Google Maps SDK or such things. So I can choose to point here, for example. That's okay, but I can also use a huge. So I will only be able to modify it on the same. Oh, sorry, misclicked. Hop. I'll delete it and add another one. And then we will open this huge plan that I will be able to also quite efficiently navigate. So that's the final version that our users are actually using. So we can add marker. We have a debug mode for viewing the viewport, but that I won't have the time to show you right now. We will get on with the end of the presentation. Hop. So what next? The main part of the component is really functional. It operates well with our users. There are still some missing parts, like double tap to zoom or go to coordinates in order to animate it dynamically. The bouncy, pinch, and pan, we did not have the time to transcribe it from the V1, so that would be good things to add. We could also add a better virtualization for the mounting and unmounting of images. That is sometimes visible. We have a drop in the frames per second because we send it back to JS. So we have minimized our exchange between native code and JS, but we still need in the state of the component to have the visible tiles, the current zoom level, and that's pretty much it, I guess. So this always calls the JS engine, so that's always a little drop in the performance. But what really would be interesting, I guess, would be to see if that could be building block for maybe a pure JS maps library. So now that React Native Maps is maintained again, it's not as important, but that could be an idea for the future of this component. For now, it's not open source; it's still in our project. But if anyone is interested in how we did it and using it for something else, we might consider making it open source. So don't hesitate to contact me if you have questions about this talk or the project that I just explained to you. And thank you for listening, and cheers.